IoT Unplugged, where we talk to industry leaders, innovators, and major players in the Internet of Things, bringing you the best and latest insights. Tune in to learn more. In this episode, I talk to Paul Williamson, Senior Vice President and General Manager of the IoT division at Arm, as we discuss Edge AI, real-world applications, and advantages, as well as key recommendations for businesses deploying Edge AI. Thanks for joining me today, Paul. Can you start us off by providing a brief introduction to yourself?
Yeah, so my name's Paul Williamson. I'm the General Manager of the IoT division of Arm. And the IoT division, we look after, we've got sort of four key divisions of Arm where we're developing our technology for. And IoT covers a really broad range of devices in the world. Everything that's not a smartphone, laptop, or a server or a car falls into our category. And our partners ship about 20 billion different devices each year in that category. Everything from little remote controls through to quite high performance robots with vision are all based in that category of compute devices.
That's a lot of ground you're covering.
Yeah, it's a pretty big market area and it makes it an interesting place to be.
Great. And can you introduce Arm as well?
Yeah, so Arm people understand probably primarily for the CPU technologies and CPU designs that we've been responsible for in primarily the smartphone market, people know us best for, but we develop the compute architecture at the heart of today's devices. Everything from those tiny little microcontrollers that are being used through to today, the largest server instances with companies like AWS in the cloud.
We're going to be talking about AI, Edge AI, and the intersection of AI and IoT, which are all quite big topics. But before we get into that topic, how are you at the company thinking about and approaching AI, given that it's such a wide, varied topic, and there are so many different ways that you can look at it?
Yeah, AI is a clearly massive topic at the moment, and feels like the narrative in the world has changed significantly from that sort of chat GPT moment of us understanding that computers can suddenly give very detailed and human-like responses. AI actually has much broader implications and applications, and we see it as something that is being applied as a new way to solve problems across all of these industries with compute. And it has some unique characteristics and demands, both in the way that you develop solutions that are going to use AI, but also that changes somewhat the needs of the compute system that is going to execute those tasks in those different markets. So we have to look forward at all of those requirements across the different markets we're operating in to make sure the compute technology that we're building is fit for the future where AI is being deployed.
Do you mind expanding a little bit on what you mean by how it changes the needs of the compute system, I think was the word you used?
Sure, yeah. So if you look at the way people have thought about computing or perhaps developing particularly an edge IoT product in the past, they've mainly been thinking about controlling things, very logical processes, decision matrix where you're sort of, if this happens, I do this. If somebody enters the room and the sensor triggers, I turn the light on. The compute gets much more complex, but fundamentally it's sort of logic-based control systems and so on. In a world of AI, we've sort of been through a lot of signal processing, wireless connectivity has come in, but with AI, we're inferring outcomes and we're able to bring in different sensor technologies to solve problems in real world applications through these complex inferences. And those inferences require mathematics and logic in the compute devices, which requires a lot more matrix focused mathematics to be executed. And that needs a slightly different set of compute functions underneath to be efficient when it's operated.
I think when we talk about AI, it's quite exciting because it feels like we're kind of just scratching the surface of what's possible.
Yeah, absolutely. And I see that every day. I see a really broad range of different use cases for AI. At the edge, that scales from tiny little sensors and devices through to some really complex applications. One example I'd give of that at the tiny end of the spectrum has been to see somebody using a small image sensor to look for, pests effectively on the leaves of plants in agriculture. So all they're doing is, once a minute or so, taking an image of a leaf and saying, "Can I see signs that a beetle has been here?" And you can use AI and image processing detection to look for those signs in a very sort of automatic way, and then trigger, targeted treatment of crops only where it's needed when that is seen. At a high level, you wouldn't immediately go, "Well, that's AI," but AI has unlocked this capability, even on a simple microcontroller system at very low power, for us to be able to do things like, "Is there a beetle there?" rather than more traditional sort of sensing, and that, I think, is just shows the power of AI type approaches, even to really simple applications.
And we will be talking about some of these real world applications in a bit. Before we get on to that, can you talk a little bit about Edge AI and how it, the key distinctions between AI and how it works?
Yeah, so Edge AI is about bringing the capabilities of AI to physical and real world devices in front of us. At the moment, a lot of people think about AI as that chatbot in the cloud, something you can submit a query to or have it generate an image for you. But actually taking those techniques and deploying them at what we describe as the edge of the network or the endpoint device allows you to do things that you can't do in the cloud. You can have real-time response to local sensors that gives you, useful decision making in real time locally. And so Edge AI is about bringing that capability down into these more constrained devices. You haven't got a massive server and a huge amount of energy at your disposal. You're working in a more constrained environment, but you're also having to respond quickly and locally to the specific application needs that you have in that edge application. And so that's what about bringing AI into those edge and endpoint devices is about.
And earlier you sort of touched upon it when you were talking about the beetle and this being a use case that's been unlocked. Have there been any applications or industries that you've seen not only are benefiting from the application of Edge AI, but previously wouldn't have had these kinds of capabilities prior?
Oh, well, absolutely, and I think there's a few that are becoming visible. We sort of a lot of this has been most visible in bringing video sensing and video type applications to life. I think probably a consumer one that people start to notice is, doorbell cameras initially emerged as, you push the bell and then you get a sort of video stream. Bringing smarts and AI into camera technology in consumer applications has meant that you can now, distinguish between whether it's bushes waving in the wind or whether it's people actually approaching the property, or is it just the dog running wild in the living room. You can actually make useful inferences and decisions locally in the end device, and that has made it both more power efficient and to bring, greater utility to people than otherwise you would have had. So that's probably one of the first areas where we've seen AI and sort of machine learning techniques applied to sensors to bring new value that couldn't have been done previously with existing techniques in devices locally.
Have there been any on the kind of industrial commercial side that you've seen benefit?
Yeah, absolutely. I think a lot of people are looking at how best to deploy. So, just as you can use that camera detection sort of technology to decide, is the dog running wild in the living room or is somebody sort of breaking into the property, you can use the similar techniques to do things that are very, very valuable in industrial applications. So, fault detection and event detection in a industrial setting with cameras is very valuable. You can use production line inspection systems that are able to now, more accurately identify issues early in manufacturing techniques, whether that be looking at, the quality of panels on a car production line, or PCB faults, or even contact lens high volume fault detection as they're going through production machinery. You can use that AI image recognition technique to identify a much wider range of issues that might be occurring in production and improve production yields. So That's been very real. But we're also seeing it, and I think perhaps one of the more sort of exciting and certainly interesting areas that I like is robotics and automation. So that's when you're getting into this higher performance and you're bringing together multiple sensors to have something that is able to, rather than just have a fixed function in a cage robot that moves one thing from one place to another, have something that can be much more adaptable. And even if that's just in terms of machinery that is manipulating and handling items on a production line, it can now be adaptive to what it's seeing in front of it using vision and AI mechanisms to manipulate and move items intelligently. So we're absolutely seeing it unlock these new, broader, more flexible capabilities in production and logistics.
I think robotics is especially an interesting area because although robots or robotic arms have been around for decades now, the kind of image of a humanoid robot might be becoming closer and closer, and that's thanks to the integration of AI, as you outlined. So I think that's a very cool area and one that will be interesting to see grow.
Absolutely. I think the humanoid and the more human-like behaviors of these devices is fascinating. And I see, as I think we've all probably seen the Boston Dynamics videos, you can see their brilliance and their limitations, but the progress is undoubtedly really exciting and impressive to see.
Absolutely. And we've just spoken about briefly the benefits, the advantages. Of course, need to be cognizant of the fact that there might be still some challenges when it comes to applying edge AI more specifically. So I'm curious to know whether there are any challenges or kind of technological bottlenecks you've experienced, and whether there have been any solutions that have come out of that.
Yeah, so I think for a lot of people, part of the early sort of challenge of AI is how do I actually make use of it in my specific application or my use case? And some things can be relatively straightforward. Bringing existing cloud-based sort of chatbots into a sort of working environment to support certain use cases is something we can see happening, very tangibly and quickly. When you come to, how do I apply AI to my particular sensing application? You do need to train it potentially or tune it to the needs you have in that specific application. So rather than having one general AI intelligence, what you're actually doing in edge cases often is building an expert system for a specific application, whether it's fault detection on a production line or some of the other examples we've already given. And that requires you to have a sort of software and tooling process to be able to tune the AI to do what you need it to do specifically and efficiently. And so a big part of what we do at Arm is trying to make sure that when developers come to their application and they're looking to deploy compute that Arm is developing into these applications, they have access to the right tools and software to be able to actually tune the algorithms for the application use case that they have in front of them. And that's certainly a challenge for developers who are new to the field today, to what are the tools they should use and how can they get the best out of the hardware that is available to them.
And do you see there being sometimes an issue around expertise? Like, as when we talk about AI now, there's obviously a lot of excitement, a lot of discussion about what it can do for these different industries. And you're absolutely right. It's about translating that to your own industry. But it is still very a new tech. It's still quite a new technology. So I'm wondering, do you see sometimes companies coming across the issue of not having people who are trained in AI? And so when it comes to deploying it, they're kind of scratching their heads.
I think that's definitely the case, and we've been very fortunate at Arm to be a company that's been able to build ecosystems around compute. And in a new area like AI, I think some of the early applications and tools perhaps were not that mature, and people would look for contract design services or other support that they could bring in to help them solve a problem they have in their particular area or industry. So we actually set up a sort of AI partner program for our embedded devices that brought some of those sort of contract design services skills to bear on end users' problems, and allowed people to use the software and tools around ARM platforms that they needed in their applications. Equally, I think the tools have matured and improved significantly. We've invested a lot in making it almost seamless to the software developer as to how the AI is executed or deployed, and to measure the performance of it in the normal software flow or developer flow that they already experience. So we've improved compilers, and we've brought in sort of software tools around Visual Studio Code and those kind of environments that people are familiar with, so that they can debug and deploy their algorithms onto embedded controllers with AI capability, with having less need to specifically understand the underlying hardware and its capabilities. And then we have partners who've built tools that have improved the sort of what they call the ML ops, or the sort of AI flow of taking that custom data and tuning the algorithm to suit the application. So companies like Edge Impulse or Keekso, who are part of the TDK business, have done a great job of pulling together tools and software that help developers tune the algorithms for the applications and the data that they have, so that they can then use the ARM-based tools to deploy on a range of different hardware solutions. But that is something that has developed over the last couple of years. But I would say progressively it's becoming more and more accessible to developers.
I suspect there is a learning curve both for the developers and both for, yourselves at Arm, where you're trying to understand when your customers are using these tools, are there still any problems they're coming up against, or is it just a case of they need to understand how to use the tools better? So I think it will be interesting to see how it develops over time. Let's talk about the real world applications. I think certainly an exciting part. How have you deployed AI? What have been some examples of how it's benefited different industries?
So I think it's fascinating. As I said, I've seen it used in everything from, like that agricultural, really deeply embedded, people using now AI in place of DSP, or digital signal processing techniques for audio in embedded devices has become a critical thing. Now we're seeing, we've talked a little bit about smart cameras and their emergence, but then we've seen it applied to really interesting and diverse areas. So I think an example that I feel pleased to see, that our staff have contributed directly to, have been working with things like environmental applications. So we had a project that was supported by a team within ARM, called AI for Bears, which was about identifying bears on nature cameras that were being deployed in the environment for tracking the population and helping to preserve a population of bears in the northwest of America. But equally, the same technology has been able to be, once we were able to, or the project was able to publish that more openly, they've been able to use that low-cost hardware to go and deploy those cameras with those algorithms elsewhere in the world for other projects. So I found that the work was being reused by within Europe for helping detect bears and give warnings, so that human and bear interaction was reduced and there was less harm and less need to control or cull bears in Eastern Europe. So it seems a sort of long way from the sort of Chat GPT example, but it shows that this technology can have profound and positive effects when it's deployed. And I suppose it also shows that those tools I discussed and the ability to deploy on ARM-based hardware that is widely available is really improving and allowing people to explore and exploit the technology in novel and interesting ways.
Yeah, it sounds like you felt like you were contributing to something that was bigger than just talking about the minutiae of AI, which is quite nice to hear.
Yeah, I'd love to say it was me, but it was a number of people within ARM, and I wasn't directly involved, but it was coming into that sort of, how can we use this for something really practical and positive? And when you know what it is capable of and you have access to those tools so widely, how can we put it to a good use? And that was a really impressive example that we were able to sort of demonstrate.
Absolutely. So, with everything we've spoken about, Paul, would be your key recommendations for businesses who might be looking into Edge AI, who might be looking to deploy it, or might be in the process of doing so?
Yeah, I recognize that the areas that people are exploring with Edge AI are very broad. And my recommendation to companies looking at this would be to look to the various sort of tools and software available for them to explore and deploy these applications. And I see the wonders of the ARM ecosystem are the breadth of options that you have out there. So you can start today deploying video-based AI using a Raspberry Pi and camera solution that you can just order on the internet, and you can get working and explore the tools that are out there. We have worked at ARM to make sure that the AI algorithms that you develop using tools like PyTorch or TensorFlow can be deployed really efficiently onto ARM-based compute, whether it's the high-performance CPUs that are in something like a Raspberry Pi, all the way down to these tiny little microcontrollers. But you can start from a very accessible developer platform to explore what it can do for your systems. Equally, if you've got very clear ideas and projects that you want to be working with, there is this broad range of ARM-based hardware and software services that are out there in the world from a range of our partners. So in the microcontroller world, there's our latest sort of ARM AI accelerators are now getting embedded into microcontroller designs. So we developed something called an Ethos U85, which supports these latest AI transformer networks in hardware. And we're able to see that now being deployed in silicon from a range of companies, companies like Aleph Semiconductor or Infineon, where you can go out, or a company called Hymax, where you can go out and you can get their dev tools today and start looking at what impact that capability can now have in your own applications in those embedded edge battery-powered devices as well. So whether it's Raspberry Pi higher performance through to these tiny little end nodes, there is equipment and tooling out there from a broad range of ARM partners where you can get started and see the impact that AI can have in your application. I think that's it presents some exciting opportunities to start experimenting now.
And you sort of alluded to it, but I think a really good point made is about the cost effectiveness of these tools, how they've become, as they've become more widespread, the cost has gone down. And so creating a solution that will have tangible impacts in the real world, like conserving the bears, is even more accessible, which I think is great to see.
Yeah, no, absolutely. And that's one of the things about Edge AI that's fascinating. You don't need a server farm to deploy AI in the real world. You can do that onto these really small embedded controllers that are quite accessible. And we're obviously at ARM, we have to have quite a long horizon. Our compute technology, like the Ethos accelerator in the latest microcontrollers, that takes several years to develop. So we're always looking ahead for what's coming next. And one of the things we've demonstrated even on an Ethos U85, which is our latest embedded AI accelerator, is the ability for it to run transformer-based networks, which are the things that are behind ChatGPT. So these are the more complex, more modern AI models that are being deployed in a range of applications. And so it's been exciting to see where that has potential in the future as well. So it might mean that in consumer devices, instead of having really limited set of wake words where you can only say volume up or volume down, you can actually ask a device about itself or its operation modes, and it give you a legible sort of human-like response to understand what's going on with the device. So we're seeing some really interesting applications as the models get more complex, and we're putting more compute capability into these devices to support that as well. So there's some interesting things coming in the future, I think.
Yep, that is quite remarkable when you think about it. Before we wrap up, Paul, is there anything else you want to mention to our listeners?
No, I'd say AI is a really exciting potential area. I think it can sort of dovetail into the skills of the software developer that's available today, but it also unlocks these really exciting new potential applications that somewhat are limited by the imagination of the developer. So, I'm excited that what ARM can do to support those developers to have impact. And there's a lot of potential out there. So engage with it. Look to the broad range of ARM silicon vendors out there and the tools that are available, because there's some really exciting applications that you can create with AI.
Well, that's a good point to end on, I think. So thank you for the conversation, Paul. It was a pleasure to talk.
Good to talk to you. Thank you.
IoT Unplugged.